Hi, and welcome to the Bare Basics lesson, Introduction to Relations. This lesson will introduce you to quite a bit of terminology, and so it's important that you get a handle on it to be able to conquer this unit. Let's begin with some definitions. And before you freak out, it's just putting formal names to things that you've been doing since grade 8. So what is a relation? A relation is a set of ordered pairs of values or variables. Each one is found by the same equation, which shows a relationship between the variables. As I said, you've been doing this since grade 8. Here's an example of one that you would have looked at in Year 9 and Year 10, and it's a quadratic. For every y value, it's found by squaring the x value. So we've got x and x squared for our x and y value. When we talk about relations in Maths B, there'll always be two variables, so these can be graphed on a Cartesian plane. As always, the independent variable is on the x-axis and the dependent variable is on the y-axis. And why they are called that we'll come to shortly. Alright, so let's give you an example. Consider the following table, which represents boat hire. So it's a real life example. We have the number of hours that someone could hire a boat for, and we have the cost in dollars that will be for the hire for that hour or part thereof. Since the cost depends on the number of hours, the cost is said to be the dependent variable because it changes depending on the number of hours that you hire the boat for. While the number of hours could be anything, so it's called the independent variable. We can then graph that, and here it is. So you can see our independent variable, which is the time, is on the x-axis, and the dependent variable, which is the cost, is on the y-axis. Now you'll see that there's a number of dots there. The line is not connected because the cost to hire is either $50, $60, $70, $80, $90 or $100. There's nothing in between. So because the dependent variable can only be certain values, we just put dots. We don't have a continuous line. Now, before we go on, we need to talk about sets of numbers, and this is most likely a new concept to you. What we talk about is for our independent variable of being able to set some boundaries to it. So we talk about different sets of numbers that we can use, and we use the letters N, J, and R to stand for some really useful numbers. Now, think back to when you first started to learn to count. You began at 1 and you went 1, 2, 3. So we started to call those counting numbers. Think of this as the natural thing to do because we start at 1 and we go from there. So N stands for the set of natural numbers. That is counting numbers. So 1, 2, 3. The ones that it just seems natural to use. As you progressed through school, you then learnt about integers, that is positive and negative numbers. So you learnt that we could also have negative numbers. Now, in this case, we use J to stand for the set of integers. So J could be -3, -2, -1, 0, 1, 2, 3, and so on. We don't use I because I stands for a completely different set of numbers that I'm not even going to mention for Maths B, but those of you who are doing Maths C will learn about them most likely in Year 12. Finally, we have the values that are not only whole numbers, because natural numbers and integers are only whole numbers, but it contains fractions and decimals that are used in the real world. And so R stands for the set of real numbers, and that's all the numbers that you can think of. It might be 1 3/4, -5 2/6, -10.62. N, J, and R are letters that you will hear as we go through our work with relations. So let's go back to a couple more definitions. Think back again to the graph that we did where the dots were not connected. That was because they were discrete variables. They include names and the number of things or things that can be counted. Now, you would have come across this term mainly in statistics before. Continuous variables include height, weight, and volume. That is, things that can be measured, and they can be any value on a continuum. They are the graphs that need to be connected. Now, sometimes the variable x may only take on certain values. For example, if x is the number on the face of a six-sided die, x may only take on the values 1, 2, 3, 4, 5, or 6, because there's no 8 or 12 on a six-sided die. So we write this in this mathematical way. X, and then we do this funky looking E in the set of 1, 2, 3, 4, 5, 6. It's actually read as X is an element of the set 1, 2, 3, 4, 5, 6. In the context of problems, let's look at these examples. So let's have a look at question 1 there. It gives us a particular relation, and it says it's described by the following ordered pairs, and it gives us 4 ordered pairs and asks us which graph matches. So all we have to do is plot those 4 points, and then we can see which one will actually match our graph. So we can see there that as we go across our x-axis from 0, 1, 2, and 3, our y values go down 4, 3, 2, 1. So straight away that rules out A and C and E, because E they go up and then stay the same. And it is a discrete set. They're all integers, therefore B is what we are looking for there. Now, questions 2 and 3 relate to this. So they say the elements of the dependent variable are. Now, the dependent variable is the y variable. So you can see there our y variable, our y values are 4, 3, 2, and 1. So we look for the answer that has 1, 2, 3, and 4 in it, which is A. And the rule for the relation is correctly described by. So we've got to think, how do we get the y value from the x value? And in all cases, if we take our y value is 4 minus the x value. So that takes our options to A and E and C. But then we actually have to look at what set of numbers it's giving us. Now, our numbers are all integers. So it's not going to be A because there is no, it's not fully connected. Okay, so it wouldn't be that. So it has to be either the natural numbers or our integers. And 0 is there for the x value, so it has to be that our value is using 0, 1, 2, and 3. So our answer there has to be E. The other answer it could have been was that x is an element of the integers, but because it only goes up into 3, x being 3, that's why they've limited it. Okay, the last thing we need to look at are the definition of domain and range. So a relation can be described as a listed set of ordered pairs, which we saw in our last example, a graph, or a rule. The independent variables across the x-axis are known as the domain, and the set of dependent variables, which goes on the y-axis, is known as the range. Okay, so we've got domain and we've got range. It's important you know and understand the difference between the two. Now, this example has a lot of language in it, the way it's written, but it's really easy to break up. So what it's saying is the set of ordered pairs, which is x and y, is defined by the equation y equals 2x. But x, the domain, has been limited because the domain is the set where X is an element of 1, 2, or 3, which is given. The range, therefore, can only be when Y equals 2 times 1, Y equals 2 times 2, or Y equals 2 times 3. So the range has to be 2, 4, and 6, and that's found by applying the rule. Therefore, the relation describes the set of ordered pairs 1, 2, 2, 4, and 3, 6. If the domain of a relation is not specifically stated, then it is assumed to consist of all real numbers for which the rule has meanings. And this is referred to as the implied domain. And that means that we can draw a continuous smooth arc as the curve. Here are some examples. So, the domain of the relation graphed at the right is, so domain goes across the x-axis. So it starts at -1 and goes through to, let's see, we've got 3, 4, 5, 6, 7. So the domain goes from -1 to 7. The range of the relation y equals 2x plus 5, where x, so the domain, is an element of 1 to 4. So what we can do is we can put 1 and 4 into the equation. 2 times 1 is 2 plus 5 is 7. And 2 times 4 is 8 plus 5 is 13. So our answer here will be B, 3 and 13. You have a go at the next two questions where they've given the domain and range to see if you can state them. If you have any questions, just ask me in class or send me an email. I realise that that's fairly high on terminology, but once you've looked at it and you've got the notes, we'll be doing some examples in class to make sure that you can really understand that. This has been your Bare Basics lesson. It's an introduction to relations. And remember, the aim of Bare Basics is to make maths more bearable.